Every decision carries consequences. Some you can see, others remain hidden until it's too late. In today's data-rich environment, the challenge isn't information, it's insight. What if every decision you made was backed by the power to see its impact before implementation? This is the power of Simio's intelligent digital twin technology. Our object-based, data-driven simulation platform creates a dynamic replica of your entire operation, continuously updated with real-time data from your systems. When you need to make critical decisions, Simio lets you simulate every possibility, change resources, adjust schedules, modify processes, see the results instantly. Our predictive analytics engine doesn't just show what might happen, it reveals potential risks and recommends optimal solutions. From reducing costs in manufacturing to optimizing patient flow in healthcare, Simio transforms complex data into clear direction. As technology evolves, so does Simio. Our commitment to innovation ensures you'll always stay ahead of what's next. Don't just hope for the best, know what's coming. Simio. Simulate what if with an intelligent digital twin. Visit simio.com today to discover how our digital twin technology can transform your operation from reactive to proactive, from uncertain to confident.
Welcome everyone to the Simio Solution Series, and it is September. So today's session, Simio 19 revealed. We're going to talk at a high level on Python. We're going to talk about some bypass, some advanced material handling, and a few other topics. My name is Dan Vasilini. I'm the Vice President of Global Sales here at Simio. Normally, if you've attended these webcasts, you will see one presenter underneath me. Today, we have a series of presenters that are going to present on these topics. We're going to have multiple different people presenting. You do not see their email addresses here, obviously, because we have multiple people. So any questions you may have, please feel free to filter them through me at the email address on the screen there. There will be some crowd participation today. We would like to get some feedback on our upcoming 2 webcasts, and I'll talk about those here in a second. You'll see the QR code flash on the screen or in the presentation multiple times because I'm going to bring that up. So if you want to scan that now, feel free. Otherwise, there also will be a survey at the end of today's call to try to get your feedback. So I'll talk about what the feedback is going to be about here in a second. All right, a couple housekeeping items before we get started. First off, please be aware that today's session is being recorded for replay purposes. If you'd like to watch this webcast or rewatch it or invite a colleague or a friend to it, it will be up on the Simio webpage in probably about 24 hours or so. We usually get it up. Right on the simio.com website, you'll see the learning area up top, and then you'll see this Simio webcast series, and you'll be able to go and watch this webcast and any other webcast that we've done from a recording perspective. So they're all out there for you to go back to. Session's scheduled today to last about 60 minutes. We try to leave a little time at the end for Q&A. We will do our best to get to the Q&A. If you do have questions throughout the presentation today, don't hesitate to go ahead and type them in the polling area on the WebEx attendee panel on the right side of your screen. Those questions will pop up. We'll get those addressed to the best of our ability in the session that you're asking about or in the section you're asking about. If it does come a little too late or we have moved on to another section, don't hesitate to still type your question in there. And if we don't get it answered today's session, at the end, if we run out of time, we always can try to email you back with your answer or you can reach out directly to me. All right. As far as future webcasts, we have 2 more scheduled for this year, for 2025. We have one about a month from now on October the 22nd, and then one November the 12th. Those sessions right now are entitled A Deep Dive into a Simio 19 Feature. This is where we're going to ask for your feedback and participation on what those webcasts might be. So you're going to see 4 specific topics talked about today at a very high level. There's a lot of new things in Simio 19. The release notes that you will be able to see, or that you should be able to see in Simio under the help panel, under the release notes, you can download those. There's other features, obviously, that have been included into our major release. What we're going to ask is, in that survey question and in the poll question at the end, is what topic or topics would you like to see a deeper dive on? So if it's bypass, material handling, the Omniverse, NVIDIA stuff, or the Python stuff, feel free to give us your vote there. If it's something else, we do have another box there. that you can give us a topic of your choice. So if there is something specific in 19 that you'd like to see a deep dive of that we're not talking about today, please let us know and we will include it. So 2 ways you can give us your feedback. Once again, QR code, top right side of the screen right now. You scan that QR code with your phone, and the poll is already open for you to give us some feedback. If you stick around to the end and or when you hit leave webcast today, you will get that poll question. The 3 poll questions will pop up. Please, if you can give us your feedback, we do appreciate it, because we would like to have these next 2 sessions, specifically customer driven. And if you give us your feedback, we will definitely do. We will rank them based upon how people vote, and we will do a deeper dive at that point. All right. So thank you for attending today. And as I said, we're going to have 4 distinct presenters today. One voice you've heard many times before, Kiara, and then you're going to hear probably 2 or 3 voices that you may not have heard on one of our webcasts or one of our solution series before. If you've attended Simio Sync or other things, you probably have heard some of these voices before. Or if you've phoned into support, you've heard some of these folks. But at the end of the day, these are going to be some new voices to you in the Simio Solution series. So once again, just one last time before I turn control over, feedback. We'd love to hear what you'd like to see in the deep dive sessions in October, November, so that we can fulfill what you guys are looking for. All right, Kira. Thanks everyone for attending, and I will turn it over to you. I'll stop sharing.
Awesome. Thanks, Dan. So just to make sure you can hear me okay?
Yep, coming through loud and clear.
Okay, awesome. So thank you everyone for joining. I am very excited to be a part of this panel of speakers to introduce or present a few new features of Simio 19 to you all. And as Dan mentioned, this is going to be a little bit more high level just to get the general idea. And then for future sessions, we'll deep dive into 2 of these. And if there's any questions or anything else that does not get addressed today, as you mentioned, please email and we'll address everything. But let's go ahead and start sharing the screen. Let me see here.
I'm glad you're also having a little bit of an issue, Kiara, since all 3 of us had screen share issues this morning.
Yeah, no, the technology is great. Awesome. Yes. I believe I have it. Can you see my screen?
Yep, you're sharing.
Okay, perfect. So as we mentioned, we're going to be introducing or presenting on 4 new features of the Simio 19 version. So the ones that we're going to be introducing or explaining today are the 4 in this sequence. So we're going to start with the material storage element and kind of the new updates there. Go through the bypass optimization add-in, Python integration, and finish with the NVIDIA Omniverse. After each portion, we'll leave a little bit of time for some questions, but also, again, if any don't get addressed, email us. So I'm going to start with introducing the material storage elements expansion and these new add-ins that support Simio and support users in modeling storage and retrieval for their facilities, warehouses, etc. And the reason why this is such a great implementation in Simio is it provides a table-based framework for modeling the storage and retrieval of different products throughout your facility. So in the typical storage, hierarchy system, typical warehouses, etc., how these are structured is you will have a larger storage area, and within that, it's going to be composed of potentially other smaller areas. And then subsequently, these will be composed of bins. And these bins may contain 1 or more different materials, products with specific quantities, specific requirements, etc. And so now with this new table-based framework that we're introducing, all of this is going to be supported by Simio natively. You will not need to add any specific custom logic or other definitions or anything like that. All of this is going to be supported through the elements directly inside of Simio. And what are exactly all these elements? What are these key components? Well, the specific components that are going to be key to supporting this specific component aspects of your facility are located in the definitions tab in the Simio instance. So if you go into definitions and you go into the inside of Simio, you'll see that there's going to be all these different elements. And specifically, the core elements in here are going to be the material, the storage area, and then storage bin. The material element is what helps us define the types of materials and the types of products that are stored inside of the bins. Now, the bin is ultimately, as I said, it defines a capacity constrained storage location, and these are going to be contained inside areas. So to give a little bit of an idea, let's say we're looking at a warehouse with racks and product inside these racks, etc. You might think of an area as the entire racking section. And then within this, we might have another sub-contained area that could be aisle 5. Within that area, we might have then, zone 1 area that's composed of various bins, the bottom layer bin, the top layer bin, etc. And then within those bins, we're going to have all of our materials. So this gives us kind of a visual idea of what we're trying to represent with all of these components. And why is this so powerful? Why is this going to be such an important aspect in the simulation space and within Simio? And so the first bit is it can help us define capacity constrained bins in areas. We don't have infinite amount of space to store all of our material. If we did, that would be amazing, but that's not real life. And we need to be able to simulate those constraints, simulate and understand how those limitations actually impact our system. And through the use of these various elements, we're finally able to add that in a much easier, straightforward manner. And then within all of these, we also have different selection rules to easily control how this inventory is accessed. Not everyone is going to have the same rules to pick what product gets selected from what bin, from what area itself. And so within here, we've now added the possibility to select what specific rules, whether it's based on time, based on priority, based on location, etc., you want to use to control this inventory. And this can mirror different strategies in your real warehouse operations and allow you to actually experiment with new ones. Another great aspect about this feature is it can help you split inventory across bins. We might not have one single bin or a specific single area that contains only one product, but we might have materials that actually need to be split across multiple racks, multiple bins, multiple areas. We have to keep track of all of that. And that sounds very complex because you have to keep track of all the materials, possible locations, where those locations are stored, possible inventory levels of each storage area, etc. But now all of that complexity is streamlined and made much simpler thanks to all these elements. And then finally, for specifically validation and also presentation, we can actually animate all of these material storage elements. We can now add a visual representation of the materials, the stocks at hand, what different products are at a specific bin, where those products are located, etc. And so that becomes really, really helpful when we're trying to validate the model, make sure that it's functioning as expected, etc. And when we're trying to present results to our management, stakeholders, our team members, etc. And so with all of that, there's a lot of benefits in being able to implement this. The first one being is that it supports a data-driven modeling construct. In Simio, as many of you have probably heard, we really, really push for a data-driven model. And the reason for that is because the data that you can put in allows this model to function with a lot more detail to mimic your real system, but it can also support in adding so much more complexity in a much easier manner. And moreover, these elements are actually aligned with pretty standard data structures in most ERP systems, making the import and application of these much easier inside of your models. And so you can easily import and configure all of that data to then model your warehouse inside of Simio. And because of that, you can also easily simulate changes, see what happens in potential scenarios by quickly setting up and reconfiguring some entries in your tables, reconfiguring bin assignments, etc., and see how goods will move to different zones, how the bins are going to respond in their inventory levels based on those changes, etc. And then lastly, this can actually support real-time inventory reservation, because now we can actually track the reservation of the different products and the different materials inside of these bins. We no longer have to sort of figure out, okay, is this material that I reserved a while back still available? And if not, we have to figure out a workaround around that, maybe state assignments to notify that this has been reserved, etc. All of this is simplified thanks to these elements. So we can reserve to prevent other logic from trying to pull material from the rack or from the storage area when it's already been reserved. And then we can track and see what is actually happening to all of those materials. If one was reserved and then moved unexpectedly, why was that? Is the product that we're actually picking up the one that was correctly reserved, etc. And so now, thanks to this new expansion of the material element, we're able to add much more complexity and detail in a much simpler, straightforward manner. And so before we jump into the next section of the presentation and discussing one of the other topics of today, I just want to pause here and Dan, see if there's any questions that have come up on this topic.
Nothing has come in yet, Kiara. And just for anyone that is potentially new to one of our webcasts, the way to type a question in or ask a question in the apps, bottom right-hand side of your screen, you should see an apps area, and the Slido app should be there, SLIDO, and that is where you would ask a question. So if you aren't aware of how to ask a question, that's the best way to do it. Type it in right there, and we will see it. That is a private area where it just comes to us. But yeah, Kiara, no questions as of right now. Go ahead and keep on rolling to the next presenter.
Awesome. Well, then we're going to continue on to the next topic, which is the bypass experimentation add-in.
Great. Thank you, Kiara. My name is Rylan Carney. I'm a developer here at Simio, and I'm going to talk about, we actually added 2 new add-ins that incorporate the bypass algorithm. Kiara, could you switch to the next slide, please? Great. So the first one is called Reject Scenarios with Bypass. You can see it in the screenshot there in the Select Add-in dropdown, which you'll be able to see inside of the Experiments view. The Reject Scenarios with Bypass add-in implements the bisection parallel adaptive survivor selection ranking and selection algorithm. That's quite a mouthful, which was designed by Drs. Linda Pei and Barry Nelson. The core purpose of the add-in is to eliminate non-competitive scenarios during experiment runs in order to decrease the number of required replications and find the subset of scenarios with the best performance. The add-in is defined for cases where scenarios are already created and only the best scenarios are relevant to your objective. So unlike OptQuest, which creates scenarios dynamically, this add-in requires the user to create the scenarios, such as with the scenario generator. On the next slide, I have the parameters for bypass. The confidence level, similar to a confidence level in any other application. Oh, Kiara, that's interesting. My screen lagged for a second. The confidence level, just like most other applications, kind of controls the aggressiveness by which you're pursuing an objective. In this case, the confidence level is the proportion of retained competitive scenarios relative to the total number of competitive scenarios, and I'll delve more to that in a second. But in other words, a lower confidence level will cause scenarios to be eliminated more aggressively, but increase the risk that a competitive scenario will be falsely eliminated. The initial replications is the number of replications to run for each scenario before eliminating any scenarios. The maximum replications is the maximum number of replications you can run for each scenario. So that's your control of, how long do I want this experiment to take? The lower bound is a way to eliminate scenarios more aggressively if your objective function has a lower bound. So if you know that your profit has to be at least 100 of whatever unit, you can set that as a lower bound, and it will help bypass find the best scenarios quickly. And the objective type is similar to OptQuest. It's either single objective or multi-objective. And in the case of a multiple objective function, each of the responses has their objective type, which you can set to minimum or maximize, and that determines how they're included in the bypass run. Kara, could you show the next slide, please? I'm actually going to run through an example just to kind of concretely explain how the add-in works. So in this case, what you're seeing on the left is a screenshot of an experiment where each replication takes one sample from a normal distribution. The mean and standard distribution or standard deviation are specified as controls. So you can see the mean varies from 0 to 7. The standard deviation for each mean varies from 0.1 to 1.2. In the experiment, there were 40 scenarios generated using the scenario generator. And it's worth noting that bypass works very well with the scenario generator because it can easily generate many scenarios, and bypass is able to quickly eliminate scenarios that don't perform well. The default bypass parameter values are used, so I didn't change anything. The defaults are good for many cases. And yeah, it's worth noting that the initial replications value is 6. So you can see that every single scenario has completed at least 6 replications. And at the end of the experiment run, you can maybe see at the bottom, only 6 scenarios remain active, meaning that those are the scenarios of interest. So every other scenario inside of this experiment, bypass eliminated, which tells us that those scenarios are not as competitive as the bottom 6. Additionally, rather than running 10 replications of each scenario, so the maximum replications is 10. So the maximum number of replications that could have run for this experiment is 400. Rather than running 400 replications, bypass eliminated most of the scenarios and told us which 6 were the scenarios of interest. And that required only 298 replications, meaning that bypass knocked off about 20% of the time it would have taken to run this experiment. As you can see from the results, scenarios with the smallest response values were eliminated first. So you can see, scenarios 1 through 15 only ran 6 replications. And, the scenarios after that took more replications to be eliminated. This is because bypass calculates a threshold based on the mean of the scenario response values. So scenarios with smaller response values, because we're trying to maximize the value of each scenario, those are more quickly eliminated. So this is more obvious if we look at the scenarios with a mean of 6. We can see that those were eliminated more slowly, right? They took the full 10 replications. Another thing to note is that the threshold at which we eliminate scenarios is also based on variance. So that's another thing we're taking into account here. So if we actually look, we can see around scenario 35, we can see it has a mean of 6, but it still hasn't been eliminated because its variance is higher, its standard deviation is higher. So it requires more replications to actually eliminate. And another big benefit of bypass is that it's fully resumable, meaning that we can increase the maximum number of replications and run the experiment again without resetting the experiment. So we can conserve the results that we have. And that also means that you could run bypass and then switch to another add-in and use the existing replication data, which is very nice. On the next slide, you can see the results after 30 replications. One interesting thing here is we can see only 2 additional scenarios were eliminated. Scenario 35, which had a mean value of 6, and scenario 36. Because the mean of the response value is set by the control, we know that scenario 36's mean actually matches the means of the remaining active scenarios. This is an example of a competitive scenario being falsely eliminated. In this case, the elimination of a competitive scenario occurs because I've run so many replications relative to the variance of the response. In general, the confidence level can be set to 0.99 to reduce occurrences of false eliminations, but that also increases the number of replications required to eliminate scenarios. So inversely, decreasing the confidence level to 0.9 would cause scenarios to require fewer replications to be eliminated, but increase the risk of competitive scenarios being falsely eliminated. And something else to point out is we tripled the maximum replications from 10 to 30 and only eliminated 2 additional scenarios. So outside of the fact that all the remaining scenarios have the same mean, this is a good example of how running bypass, specifically the reject scenarios with bypass add-in, can begin to have diminishing returns. Bypass by itself is the right tool for removing poorly performing scenarios, but it isn't the right tool for finding the best scenario. On the next slide, I've shown an example. It's the same normal distribution example, but we're using a different add-in. We're using the select the best with bypass add-in. So the select the best with bypass add-in still runs bypass, and it runs the bypass algorithm followed by Reinhart's procedure to find the best scenario. The add-in uses the same parameters as the reject scenarios with bypass add-in, but adds an indifferent zone parameter similar to the KN or GSP add-ins. The indifferent zone is the smallest meaningful difference in your response values. So all scenarios with response values within the indifferent zone are considered equally competitive. Reinhart's procedure, all it does is it takes the existing replication results, then calculates the number of additional replications required to find the best scenario, given the specified confidence level in a different zone and the response variance. After running the additional replications, the scenario with the best response value is selected as the best scenario. As you can see from the results, scenario 39 is selected as the best scenario because it has the largest response value. However, all scenarios with a mean of 7 fall within the indifferent zone. So if any one of them had, a slightly larger response value, any of them could have been selected. This approach only takes 334 replications to find the best scenario, whereas running reject scenarios with bypass with a maximum of 30 replications required 381 replications. And it's actually funny, both options require fewer replications than simply running 10 replications of each scenario, which of course would have required 400. So to summarize, 2 bypass add-ins, one of them to find the subset of best scenarios, but it has diminishing returns. It's not designed for finding the best scenario. One of them for finding the best scenario starting with bypass and then switching to Reinhardt. And it just in general, if you're only interested in either the best or maybe the best subset of scenarios, using bypass instead of just running a full experiment might be the way to go. That's all I have for now. For more information, you can check out the documentation, which contains a more thorough description of the add-in as well as the math behind the algorithm. Dan, are there any questions on this topic?
Yes. So you have a popular topic, right, Rylan? In the interest of time, there were 4 questions that came in. 3 of them I'm going to ask. 1 of them I'm going to hold to the end. And if we do have time at the end, we'll get to it. If not, the person that asked the question that I don't read off right now, please feel free to reach directly out to me. So the first question I'll address, the question was, is bypass an add-on similar to OpQuest, or is it additional license? No, bypass is included right in the release of Simio. The 2 questions that kind of piggyback on top of each other, Rylan, were the first one is, where is the bypass function in Simio? How do you get to it? And then could you differentiate bypass versus OpQuest in, I don't know, maybe 30 words or less? Is that something you could do pretty quickly?
Yeah, sure. To find the add-in, it's in the exact same place the OpQuest add-in is. It's just if you go to the any experiment, you'll see a select add-in dropdown. If you drop that down, you'll see it as an entry. Both the reject scenarios with bypass and select the best with bypass add-ins should be in that dropdown. As far as the difference between bypass and OpQuest, OpQuest will generate scenarios for you and attempts to find the best response value. Bypass will take existing scenarios and attempt to find the best response value. And the other key difference is OpQuest has no statistical guarantees. So it's attempting to find the best, but it has no guarantee that it will find the best. Bypass has statistical guarantees about the confidence that it will find the best. So if you know what you're testing, bypass is the way to go. Or if you're willing to run a lot of replications, whereas OpQuest is more of you want to explore the space and maybe find the area which might have the best response values.
Perfect. Thank you, Rylan. All right, and like I said, if the person that asked the question that I did not read off, please feel free to reach out. If we don't get to it at the end, we have 2 more topics to go. We might be able to get back to that question, but I think just by reading the question, I think it's a pretty in-depth answer, so it might be one of those ones we either take offline and address, or please put your suggestion/vote in for bypass being one of the topics we do a deep dive on in less than a month. All right, Ryan, thank you. Kiara, next person.
All right.
The next topic is
so this.
Here we go.
Oh, sorry, Kiara. I'm just jumping in. Yeah, this is Paul, and I'm going to talk about Simio and Python. So you can go to the next slide, and just a little bit of setup here about how you can use Python and Simio together. So 2 ways that exist today. You can use Python with our portal application, taking advantage of the API, and potentially our PySimio package to go along with that. Many of you likely use Python today to do upstream data cleaning, transformation, and validation. And so I'm excited today to talk about using Python inside of Simio as a Python step and how we can use that. So next slide, please. Okay, so starting with Simio version 19, you'll be able to call custom Python code directly within your process logic. I'm excited to introduce this and we'll walk you through a little bit today, but as Dan mentioned, we can go into more detail in follow-up calls. On the right-hand side of the screen, you'll see a new scripted steps section that's under the definitions tab. From there, you can now create a new scripted step, just like any other step in Simio. In this case, we're going to create one called choose server. Each scripted step can have custom properties. These are values you'll want to pass in from your model into the Python script. For example, you can pass state values, entity references, or model parameters. When you select a scripted step, you can then click the Edit button, which will be in the top ribbon, and Simio will launch the local IDE. That could be VS Code, PyCharm, or another editor, and you'll be able to work within that, and you can create and paste your Python code there. You can also import packages, write logic, connect to APIs, perform calculations, whatever your use case requires. Once you've saved your script, that Python logic becomes a reusable step that you can now drop into your process logic, just like any other Simio step. We expect this to open up immediate opportunities for custom calculations that are hard to do in standard Simio expressions, API integrations with other external systems, or anywhere else that Python gives you more power and flexibility than Simio's logic. Let's start with a simple use case, data calculation. Next slide, please. Okay. So one of the things Python does really well is data-driven calculations. You can now bring that capability directly into your Simio models. With just a few inputs from your simulation, like entity states or timestamps, you can now call a Python step, and it can perform real-time forecasting. It can do curve fitting, or it can dynamically estimate processing time. It's fast, flexible, and completely embedded within your process logic. This gives you a powerful alternative to traditional Simio expressions, especially for complex or nonlinear logic that would be difficult to manage inside of Simio. Another major advantage here is you no longer have to embed large reference tables inside your model. Instead, your Python script can act as a smart calculator. It can take a few values and look up or compute that answer externally and return the result to Simio instantly. Instead of your Python's, and now we can also look at how Python can link to real-time external controllers. Next slide, please. I think this is another exciting use case where you can link your simulation directly to something outside of Simio. Let's say you're working with a warehouse automation project and you want to consider the addition of AMRs. If you've tried to do this in simulation before, one of the first steps is you have to build the logic around fleet management. That is deciding when the AMR gets assigned to what task, how to do it, things like that. Traditionally, this means recreating all that logic within Simio. Now with Python steps, you can do something much more realistic. You could call the AMR Fleet Manager by the API inside of Simio. So imagine this, a robotics provider gives you API access to their control system. They'll tell you what data they need. For example, it could be the zone, the order count, load size, whatever their typical inputs are. And you configure a Python step that'll send that data during the simulation. So we're going to grab that location, those orders, information, whatever it is from the simulation run, and we're going to pass that by an API out to the fleet manager. The fleet manager then can return a response to us, which we can use inside the simulation. It could be an estimate of the ATA. It could be something as simple as this priority 2 that I show coming back. This enables you to get a realistic view of what that system will do without having to recreate any logic. I think this is really going to speed up development and the accuracy of simulations. It'll also open up some new opportunities for testing and validation, especially in pre-deployment or other situations where the system's getting ready to come online and you want to see at the last minute before you go in and do that testing how the system should react. Okay, so with that, let's go to the next slide and we'll talk a little bit more about what's next on the horizon as far as Python. So this is all available now in Python version 19 as far as steps go. As I mentioned in the lead-in, you can also use Python with Portal. And very soon we'll be bringing in the ability to use Python as a data importer and exporter. So look for an updated release of version 19 later this year, where you can now run Python scripts and connect to data sources, do data transformation and cleaning, and bring that directly into Simio. I'm personally pretty excited about that. I think that's going to really enable a lot of our users to build prototype and even production data pipelines as a part of Simio. And I'll wrap up here with one final slide. If you can advance the next one, Kiara. And just a little bit about how I think Python integration is going to change Simio and simulation for our modelers and users. So I think on the modeler side of things, obviously we're going to get faster on our development cycles. You can use existing Python code or write small pieces of Python code to get started. Also more automation and greater flexibility to connect with other systems. As far as data scientists and analysts, I think it's going to open the door for data professionals to connect with simulation in ways they haven't been able to before. So those of you that work in large companies, you can now partner with your data scientist colleagues and have them help you write scripts to do data analysis and provide outputs to visualization tools, things like that. Business users, they may not be writing code here, but they're going to get benefits of more intelligent decision support. So Python's going to bring a wealth of ability to transform and translate data from the simulation into understandable information for our business users to make better decisions. I think that'll also come in the form of more automated reporting and a broader range of what-if scenarios that can be searched. Finally, with our IT and engineering partners, between Python and REST APIs, it's going to allow Simio to fit more naturally into the enterprise architecture. Python is easier to integrate with data pipelines. It'll allow us to do more and different types of authentication and allow us to work with other cloud and analytics technologies. So to summarize, we think Python's not just about scripting here. It's about making Simio more scalable, faster, and more integrated into the digital ecosystem. So with that, I'll pause and take any questions.
Perfect. All right. Once again, questions rolling in on this one. I'm going to get to a few of the ones that we can knock off pretty quickly, and we might have to hold off on the rest, but we'll see what happens here. Paul, any SimBit examples which can provide the use case on how to use Python and Simio?
Yes, I believe we have one that shipped with it, but I don't recall off the top of my head what it is. I'll get back to you on that one.
Okay. All right. So for the person who asked that question, please feel free. I'll flash my email address up once again at the end, and please feel free to reach directly out to me, and I will get the SimBit example back to you. Does Python integration offer additional APIs within the I-execution context that are not available to C#?
Not that I'm aware of. I believe we're using all the same execution, all the same endpoints there. So if you once you see this in version 19, right next to the edit button is a API documentation button, which will take you to that. There's nothing new or anything that we changed and opened up on the Simio API. But if there is something, obviously, let us know what you're looking to do, and we can look into it.
All right, and someone just chimed in on the Simio side, Paul, that there are example models and documentation in the Simio GitHub, and I can send the GitHub link out to the person that asked the question in general, or I can send it to everyone. So if you are interested in that, in the examples, it is in the Simio GitHub.
Okay.
Two additional questions on the academic side. Is Python going to be available in the academic version, and when is Simio 19 going to be available to academic users? So the academic version includes the exact same type of stuff that the commercial version does. There's no limitations to it. As far as the availability, it is available now. All right. Let me check, see if there's any more questions I didn't ask. All right, there's one more question. I'm going to hold off on that, and let's jump into Caleb's last presentation. We'll see if we have time left, okay? Thanks, Paul.
Thank you.
All right, yes, I'm Caleb. I'm a senior engineer here at Simio, and today I'm going to present on Simio and the real-time digital twin visualization link with NVIDIA Omniverse. NVIDIA Omniverse is a powerful platform built on universal scene description technology that enables the creation and operation of photorealistic 3D simulations and digital twins. This revolutionary environment serves as the foundation for next-generation visualization, providing near Pixar-level animation quality rendered in real time. At the core of this technology is the Nucleus server, which manages and serves USD scenes with exceptional fidelity. The NVIDIA Omniverse platform transforms how organizations visualize, validate, and optimize complex systems by creating immersive digital environments that precisely mirror physical operations. Through Simio's advanced integration capabilities, this powerful visualization technology seamlessly connects with industry-leading simulation models, creating digital twins that combine analytical precision with visual impact. This integration represents a significant advancement in how organizations leverage digital twin technology to drive informed decisions through interactive, high-fidelity environments. OpenUSD, which stands for Universal Scene Description, was originally developed by Pixar and is an open, extensible framework for the interchange and collaboration editing of 3D scenes. At its core, OpenUSD is a scene description format and API that enables highly scalable, non-destructive workflows for complex 3D content. It allows multiple users and applications to work simultaneously on the same scene without conflicts. It supports rich features such as layering, variant sets, asset referencing, and instantiating, making it ideal for modern collaboration environments. It emerged as a foundational technology across industries like film, gaming, simulation, industrial design, thanks in large part to its adoption and expansion by NVIDIA Omniverse. NVIDIA Omniverse is a real-time simulation and collaboration platform for 3D content creators and engineers. OpenUSD is the backbone of Omniverse, enabling interoperability between different tools and users. By leveraging OpenUSD, Omniverse allows diverse software applications to exchange and co-edit assets in real time without converting file formats or losing fidelity. To get started with Simio's Omniverse integration, you will want to go to the Simio LLC GitHub page, which Dan mentioned earlier, and then download the Simio Omniverse connector folder from its repository. This folder contains 8 additional steps, a new element, and a new connector that allows you to have your Simio project interact with NVIDIA's Omniverse. Once you download and unblock the zip file, you will want to extract the files to the C program files Simio LLC Simio user extensions folder, and then restart your Simio to ensure that the new extensions are recognized. The zip file from the GitHub also includes an example model that we'll cover in the next few slides. So what makes this so powerful? First, real-time bidirectional communication. The Simio NVIDIA Omniverse integration creates a seamless connection between simulation logic and visual representation. This includes live model updates. Simio sends continuous updates to the Nucleus server, driving animations including object movement, creation, and destruction in real time. Also, this includes interactive input capabilities. The platform supports bidirectional data exchange, allowing visual interactions or external triggers within the Omniverse to influence simulation behavior and parameters. Lastly, perfect synchronization. When a simulation pauses in Simio, NVIDIA Omniverse also pauses. This maintains precise alignment between operational logic and visual representation at all times. Another powerful tool here is the photorealistic visualization. You can transform abstract simulation concepts into compelling visual experiences that communicate complex ideas with extraordinary clarity. This includes high-fidelity rendering. We can leverage NVIDIA's advanced rendering technology to create stunning visual representations of your operational systems with unprecedented detail and realism. This includes immersive environments, which enables stakeholders to visualize and interact with simulations in intuitive, compelling environments that reveal insights impossible to discern from traditional representations. Lastly, there's enhanced communication. You can bridge the gap between technical and non-technical stakeholders through visual storytelling that transforms abstract data into concrete, accessible insights. Finally, there are advanced digital twin capabilities. The integration between the two elevates digital twin implementation with capabilities previously unattainable through conventional approaches, such as comprehensive system visualization, where you can visually monitor the entire system and observe real-time reactions to Simio logic, whether you're monitoring equipment movements, material flow, or operator activity across complex operations, dynamic parameter adjustments, where users can modify simulation parameters in real time and immediately observe the visual impact of those changes, can accelerate the optimization process through intuitive feedback. Lastly, the AI-ready framework creates a foundation for artificial intelligence agents to observe operation patterns where they can learn from system behavior and potentially influence simulation performance through adaptive algorithms. On the Simio GitHub page, there's a warehouse example USD file as well as a corresponding SPFX file that we will demo in the next slide that shows an easy way to get started with integrating Simio with the Omniverse. As the forklifts move in Simio, they will move real time in the 3D scene by updating the position and orientation in real time. A user can adjust the forklift speed in the Omniverse, and Simio will read that data in from the USD during runtime. In this video, you can see Simio on the left and the USD composer on the right. As the Simio run begins, you will notice the forklift is created in the facility view on the left, but if you look to the Omniverse on the right, you will notice that the forklift has also been created in that session. You can see in both windows that the movement is identical. What happens in one happens in the other. When the forklift enters the sink in Simio, it also leaves the Omniverse. So why use Simio for NVIDIA Omniverse integration? The integration of Simio's discrete event simulation with NVIDIA Omniverse creates a powerful synergy that addresses the fundamental challenge facing digital twins, balancing analytical precision with intuitive understanding. While simulation provides the mathematical foundation for accurate operational modeling, capturing complex system dynamics, variability, and interdependencies with statistical precision, Omniverse transforms abstract data into intuitive visual representations that reveal spatial relationships and physical constraints impossible to discern from numbers alone. This combination delivers comprehensive operational intelligence by compressing time while maintaining spatial awareness. Simio's technology accelerates time while allowing organizations to evaluate months of operational performance in minutes, while Omniverse adds crucial space context by accurately representing physical environments and movement constraints. Together, they ensure optimized solutions work not just theoretically, but in actual operational environments with real physical constraints. The integration bridges the communication gap between simulation experts and decision makers by pairing statistical insights with compelling visual narratives. Complex concepts become accessible to stakeholders regardless of technical background, building consensus around improvement initiatives, both through rigorous analytical evidence and intuitive visual demonstrations. This communication advantage significantly accelerates implementation and adoption of optimized solutions. Organizations implementing this combined approach typically experience faster project approval, more efficient implementation, and greater sustained adoption of optimization initiatives. The integration delivers ROI through multiple complementary pathways. The quantifiable benefits of improved throughput and resource utilization from simulation enhanced by accelerated stakeholder alignment and reduced redesign costs through early visualization, identification of potential issues. This comprehensive approach creates digital twins that drive measurable value across all stages of operational improvement. And with that, I'll take any questions.
Perfect. Thank you, Caleb. All right, there's a question being typed in right now, so hold tight on that. Rylan, are you still here? Just to circle back to one of your questions.
Sure.
All right, perfect. So let's go back to one of the questions on bypass, and then Caleb, as soon as this question gets typed in fully, I will I'll ask that, and then we'll wrap up. So I'm going to try to keep this question kind of brief, Rylan, but if you need to go on in more depth, feel free. The question was, can you give a definition, like a technical term, of how Simio understands competitive scenarios? In other words, what exactly does that mean, competitive? And can that definition be modified by using different parameters, ranges, variables, etc.?
Competitive is actually not a Simio term. That's a term used by the creators of the algorithm. In terms of the algorithm, competitive just means best. But because best is usually used to mean like the one best scenario, they use the term competitive to essentially mean the subset of the best scenarios.
Okay. And can that definition be modified, or is that?
I guess it depends on how you think about it. It could be modified in the sense that if you have multiple responses and some of them are minimized responses and some of them are maximized responses, as well as like you can set the response weights. So one response might be very important to the objective function, and one might not be. Then in that sense, yes, you could change what is best because you're kind of defining what it means to be the best. But you can't do it by setting like one of the bypass parameters itself. You can just do it with the response parameters. You can maybe make the argument that in the case of the select the best with bypass, where you use Reinhart's procedure, that you could maybe change the definition of what's best by changing the indifferent zone. But I don't know that that really holds up because the indifferent zone is a range defining like what I want the best within this range. So I don't know that that's really changing the definition of what's best. It's just changing what you accept as best. So I guess the way to do it is really just the response parameters, the weights, and whether you're minimizing and maximizing each response.
Okay. All right, perfect. Thanks for the in-depth answer there. And bypass might be something we're coming back to in a future webcast. So if we have to go in depth, we will. All right, a couple questions on Omniverse here. I know we're just about out of time. Let me get to a couple of these, and I'll put my email address back up there just in case we didn't get to anything. The question, the first simple question I think would be, where is the Omniverse extension available in Simio? How do you get to it?
Yes, so it is not in your Simio install by default. You'll have to go to the Simio GitHub page. If you just Google Simio LLC GitHub, you can go there, and you're going to want to look for, there's a folder called Simio Omniverse Connector. There's a folder there. You'll want to download that and then put that into your user extension folder. Once you do that, restart your Simio, and then you should see those 8 steps and new element and new connector appear in your Simio instance.
All right, perfect. And I'm 99% certain I know the answer to this question, but I'll ask it for an answer just to be certain. In order to utilize Omniverse, would a company be exposing any type of proprietary data in their models to NVIDIA?
I'm not 100% sure on that answer. I can look more
I can
into
take that one, Caleb.
Okay.
So generally, you don't have to in any way. It all depends on your network setup, but most of the time you actually start with a local instance of Omniverse, so you're not going to take anything outside of your 4 walls. From there, NVIDIA can offer a cloud-based version or an on-prem version, but that's going to be through them and your architecture.
Perfect. Thanks, guys. All right, last question, and then we'll wrap. I know there are still a few people typing questions still. We can see them being typed, but we're probably going to run out of time. So where does the graphic actually come from? If you have an engineering drawing of a geopalette material handling carrier, can you use it to generate the graphic to its true 3 dimensions?
So from my perspective, I believe that you have to convert the graphic into something that the Omniverse can read in, and then you'll upload it to your Omniverse nucleus. That's that USD we were talking about. So if you go into the GitHub example, there will be a file, and it's a .usd file. So that will, you'll upload that into your nucleus, and then that goes along with the corresponding model. So I believe you just have to have a file format that the Omniverse can read in.
Perfect. All right, let me just go back to sharing my PowerPoint one more time here for email addresses. So there's my email address on the screen in case you didn't get it at the beginning, dvasilini@simio.com. Any questions that you might have typed in today that we didn't get to, or if you were typing a question and you didn't have a chance to finish the question, feel free to reach directly out to me. I will get that question onto the appropriate person. As I mentioned at the beginning, feedback, participation, whatever you want to call it, we're really looking forward to that, as we have 2 sessions coming up, as I mentioned. In case you weren't here at the beginning, October 22nd, November 12th. We have 2 more sessions coming up that we're playing a deep dive on a specific topic in Simio 19, and whether that is a deep dive on one of these topics we talked about today, or obviously we encourage everyone to take a look at the release notes available inside of your Simio install. If there's something specific in the release notes that you say, well, you know what, this is of great interest to me. I'd love to have a deeper dive on this. Also, there is going to be an other option for you to choose when you vote on what you'd like to see in the deep dive. Please type in that other option. If when you're leaving today's session, you will get this questionnaire. If you don't have a chance to answer it right now, there's also that QR code, or if you are watching this recording, there's the QR code right there for you. Please scan that QR code and provide us some feedback. Otherwise, thanks everyone for attending today. We appreciate it. From the Simio team standpoint, thanks everyone for putting your time in and presenting this. And we look forward to seeing everyone here in hopefully about a month with our first deep dive topic. As soon as we have it decided on what these are going to be, we will be sending the email out and saying on October 27th or 22nd, we're going to deep dive into X. And then on November 12th, we're going to deep dive into Y. Once again, thanks everyone for attending, and we will see everyone in about a month. Goodbye.